Silmafemen. Oiknis proteste haerete. Airenikos prosphilus elelistamen philoi.
Paz e felicidade a todos.
各位好嘛，祝各位平安健康快樂。
Adanishlu shulnu.
Здравствуйте, приветствую вас.
What you have just heard came from the Golden Record, a gold-plated copper phonograph record that contains an array of sounds and images that represent us and our planet. It was attached to the Voyager 1 and Voyager 2 space probes that were sent in 1977 to study the outer planets of the solar system. Carl Sagan, an astrophysicist who played a key role in the creation of the Golden Record, envisioned it as an opportunity for humanity to potentially connect with extraterrestrial civilizations. Our planet, where life as we know it found optimal conditions to emerge over billions of years, may seem like a miracle compared to the majority of planets we know. However, the enormity of our universe, particularly our galaxies, makes even the rarest occurrences potentially abundant. According to estimates by the Kepler team, there are approximately 500 million planets in the habitable zone within our galaxy. This statistical likelihood raises the possibility of the existence of life and, potentially, another intelligent civilization somewhere around another star. Astrobiology is a scientific discipline that explores the potential for extraterrestrial life and the conditions that might support life in the universe. This field combines principles from biology, chemistry, physics, astronomy, and geology to understand the origin, evolution, and future of life in the cosmos. Stay with us as we delve into a journey in the realm of astrobiology, exploring the mysteries of life beyond Earth. But before we begin, if you are new here, don't forget to give us a thumbs up, subscribe to the channel, and hit the bell for notifications. Now, let's embark on our journey. One crucial factor in determining a planet's habitability is the concept of the habitable zone, often referred to as the Goldilocks zone. This zone designates an orbital region around a star where conditions are just right for maintaining liquid water, a vital ingredient for life. In addition to the habitable zone and water, several other factors contribute to a planet's potential host of life: a protective atmosphere and a magnetic field that shield it from harmful cosmic radiation. Essential chemical building blocks, including carbon, nitrogen, oxygen, hydrogen, phosphorus, and sulfur for the creation of complex organic molecules. A long-lived star, such as an M, K, G, or even F-type main sequence star, allowing for the gradual development of life over billions of years. Astronomers have discovered plenty of planets in the habitable zone within our galaxy. Among them, Proxima Centauri b, an exoplanet orbiting the star Proxima Centauri, a red dwarf that is the closest star to the Sun, located 4.24 light-years away. TRAPPIST-1, a red dwarf star located 39 light-years away that stood out for hosting 7 Earth-sized planets, several of which are located within the habitable zone. Kepler 186f, located 500 light-years away, it was one of the first Earth-sized exoplanets to be discovered. It orbits a star in the Kepler 186 system. Kepler 62f and Kepler 62e, 2 exoplanets that are part of the Kepler 62 system, which is 990 light-years away. Kepler 22b, a super-Earth-sized exoplanet orbiting a Sun-like star 620 light-years away, and many more. But within our solar systems there are moons that are believed to have a subsurface water ocean beneath their icy crust. Europa, a Jupiter's moon that is thought to have a global ocean that contains more than twice the amount of water found on Earth, and to which there would be some future missions, such as NASA's Europa Clipper aiming to study Europa's subsurface ocean and its potential habitability. And Enceladus, one of Saturn's moons known for its eruptions from cracks in the surface. The Cassini spacecraft detected plumes of water vapor and icy particles emanating from it, providing evidence of the subsurface ocean. Even though these 2 moons are far beyond our Sun's habitable zone, which means there is not enough solar energy for the emergence of life. The primary energy source for life might come from a process known as chemosynthesis, a form of biological production where organisms use chemical reactions to produce energy instead of relying on sunlight. And, of course, we won't forget about the red planet Mars. It used to be one of the 3 habitable worlds in the early days of the solar system. It used to have rivers, valleys, lakes, and even oceans of liquid water. However, since it lost its magnetic field, solar winds blew away its water and atmosphere, turning it into a cold and dry desert. Recent discoveries suggest that liquid water may still exist underground in some regions, particularly in the polar regions, which suggests the possibility of present or past microbial life. If life exists on Mars, it might take the form of extremophiles, microorganisms adapted to harsh and extreme conditions, such as low temperatures, high radiations, or low water availability. Scientists are searching for biosignatures on Mars indicating any past or present life. They have detected methane and organic molecules, which raised intriguing questions because methane can be produced by geological processes, but it can also be a byproduct of certain microbial life. And there would be upcoming missions, including the Mars Sample Return Campaign by NASA and the European Space Agency, that aim to collect and return Martian soil and rock samples to Earth. Analyzing these samples could provide valuable insights into Mars' geological history and the potential presence of biosignatures. Switching from the search for microbial life to the quest for intelligent beings, let's discuss SETI, or the search for extraterrestrial intelligence. SETI is a scientific effort focused on detecting signals or signs of intelligent extraterrestrial life. Its primary goal is to answer the profound question of whether humans are alone in the universe or if there are other technologically advanced civilizations beyond Earth. The roots of SETI can be traced back to the work of astronomer Frank Drake, who initiated the first modern scientific search for extraterrestrial intelligence in 1960. Using a radio telescope, Drake listened for signals from nearby stars. He also formulated the Drake equation, a probabilistic formula estimating the number of active, communicative extraterrestrial civilizations in the Milky Way. The equation takes into account factors such as the rate of star formation, the fraction of stars with planets, and the likelihood of life evolving on those planets. In conclusion, our exploration of astrobiology reveals a vast cosmic landscape with potential for life beyond Earth, from planets in the habitable zone to moons with subsurface oceans and the once habitable Mars. The search for extraterrestrial life takes various intriguing forms. Ongoing efforts, like the search for biosignatures on Mars and the SETI initiative, focused on detecting intelligent signals, highlight our persistent curiosity about life beyond our planet. Thank you for being with us. If you enjoyed the video, please subscribe, hit the bell, and share your thoughts below. Let's uncover the world's secrets together. Stay curious, stay connected, and join us in exploring the unknown. See you next time.